These are podcast answers for for Energy and Power, Year 13 AS1 past paper questions. So this section is all about energy and power, and it's January from 2000, and it says 2004. The first question is actually 2003 up to 2009. We'll just scan in a wee bit. The first question is from Jun2003, and the question asks, explain what is meant by gravitational potential energy. So gravitational potential energy is energy that an object possesses due to its position or height. Just checking how many S's. I don't think that looks right, but because of its height or position. And it's above the Earth, because gravitational is above the Earth's surface. Part B, a model helicopter of mass 0.6 kilograms initially on the ground rises vertically into the air with uniform acceleration. At a height of 35 metres above the ground, its speed is 5.9. Calculate the change in kinetic energy of the helicopter as it rises from the ground to a height of 35 metres. So kinetic energy is a half mv squared. And we're just going to say delta v squared, as in the change. So that's a half times the mass is 0.6 kilograms. And the change in v, it goes from 0 up to 5.9. So it's 5.9 that is squared. And that gives you an answer of 10.44 joules. So 10.4, we'll just write joules is your answer. Part 2, calculate the change in gravitational potential energy of the helicopter as it rises to this height. So the change in gravitational potential energy is calculated by mgh, and its change in height is from 0 again up to 35 metres. So it's 0.6 times 9.81 times 35, and that gives you 206 joules. Part 3, hence find the total force required to accelerate the helicopter and move it to a height of 35 metres. Right, so the total work that was done is equal to the 206 to get it to that height, plus the 10.54 joules of kinetic it gained. So it gained 206 of GPE. And it gained 10.4 kinetic. So altogether, that's 216.4 joules. And work done is force by distance. And therefore, force is work over distance. And so that's equal to 216.4 divided by the distance is 35 metres. It's travelled. And so the answer comes out to be 6.2 newtons.